All right, folks, Infinite Limits 3 has a few problems that we need to learn. Uh, I'm going to review some other things, but first I want to talk about that we're going to see more indeterminate forms of 0 over 0. And for the first one, you need to factor and reduce. For the second grouping, you'll need to rationalize, factor, and reduce, and then some other comments. For example, when you see this problem, it's like number 11. When I substitute the 3, I have 0 over 0, and automatically, since there's no radicals or anything, I know that I need to factor and reduce. So I factor out the negative sign, or -1. I reduce, and now when I go ahead to evaluate, I'm going to get -1 over 0. Now doing part 2, 2.9 makes it negative, and so I end up being positive infinity. Now, problems 10 through 12, you get to factor and reduce, but it's your choice if you want to or not. So to factor and reduce or not, you get to choose. So over here, notice it's easy. I always just plug in first if it's simple arithmetic. And I get 6 over 0, 2.9 makes it negative, so I have negative infinity. But your pencil may not have been able to help itself. It might have just seen those. And by the way, I want to be honest, when you get into college, they don't expect to see this. They assume you can go from step 1 here all the way down to there, that you should know a difference of squares by heart and not have to show extra work, and nobody would demand it. Now, from the left, 2.9, I plug in, instead of 6 over 0 negative, it's 1 over 0 from the left, and it's still negative infinity. Now, we have two more problems that you students want to argue, but, I can think this in my head by just plugging in a number. It is useless to argue. You're going to be required to show your work, so just do it. Your college professors don't care if you can think about it. You need to rationalize, factor, and reduce these. So for the first problem, I insert my 5. Notice 5 from the right is legal, 5 from the left isn't, because 4.5 would make under the radical a negative, and we can only do limits when they're in the domain, or automatically, if it's not in the domain, it's D and E. And so any number bigger than 5 is legal. And so, but when I insert the 5, I get 0 over 0, so I have to do more algebra. So now I'm going to rationalize by numerator, but be careful, this is not a difference of squares. This is simply a single radical, like square root 2, square root 5, square root 10. So you're just going to rationalize a monomial radical. Don't worry about the radicand. The radicand might be a difference of squares, but the radical is not a radical plus or minus a number. And so the numerator just becomes x squared minus 25. And again, I went ahead and showed the factoring. But if you know that, oh, this is x plus 5x minus 5 in your head, they'll let you jump from this step down to that step. So feel free to do it if you understand that. So inserting my 5.1, I see it's 0 right, and 10, and the square root of 0 slightly bigger than 0 is still slightly bigger than 0, and so I get positive infinity. Now notice when I go to do this one, I have to use the left, because if I use 5.1, that will be a negative number and illegal. So my domain is anything smaller than 5. 4.9999999999999999999999999999999999999999999999999999999999999999999999999999999 is okay. I can't use 5. So I go ahead and insert my 5 and get 0 over 0. And now I'm going to rationalize. Again, it's just a single radical like square root 2, so square root 2 over square root 2. I go ahead and multiply the rationalized part. Again, I can do all this factoring, but if I already know that this is just negation of x squared minus 25, I can skip from here down to there without anybody arguing, because I should know this is x plus 5x minus 5 times -1. That should be in your brain just from Algebra 1. So now I'm getting negative 5 plus 5 over square root 0. Insert my 4.9. Yes, it's positive. I can do the square root of a positive. And so I end up with negative infinity. Some last comments. Problems 13 through 15 are going to lead you through a problem to keep you from getting caught with your pants down. Notice this has a left. Very easy. I'm going to get negative infinity. This indicates from the right. Again, very easy. But now careful. This one doesn't tell us anything. There's no extra info. Now, I know you want to just say D and E, but in mathematics, you're not allowed to do that. You have to look left and right to say they don't agree, to say that your limit does not exist. We've understood that. So now this is at a vertical asymptote, and you know a vertical asymptote has a left side and a right side, so it's acting in a sense like a jump. But since we just did the left side and we just did the right side, it would then be legal to just say D and E here, because we know that the left side answer did not equal the right side answer. But what happens if they just give you this problem and you get 1 over 0, no decision? You're sure it's probably going to be D and E. You're probably 99.99% sure. But you still have to show the work. You still have to show the left side goes to one infinity and the right side goes to the other infinity. Yes, you've got to do it all before you can conclude D and E. The rest of the worksheet that you're going to do, so all these examples were on page 2. Page 1 is like the original page 1 worksheet. When you get to problems 18 on this worksheet, those problems are just going to be like what we learned on worksheet 2, a little review.